Hi, I am Gyeong-In from FriendliAI, and thank you for joining us today. In this session, I am going to talk about scaling generative AI inference at trillion token scale. Before getting started, a little bit about me. I am CTO at FriendliAI, and I build technologies for Gen AI inference acceleration. In 2025, more and more people talk about AI inference than before, and we are seeing a growing demand and importance of inference. This is primarily due to the large-scale adoption of AI in our daily life, including open source AI models. In these days, companies are training fine-tuned model starting from an open source foundation model instead of training the models from scratch. Because of that, we are seeing an increasing number of GPUs are now being used for inference rather than training. Secondly, we are seeing increasing computation use at inference time to unlock greater intelligence. Starting from OpenAI's O1 model, we have a bunch of reasoning models at the market, and companies are starting to adopt these reasoning models into their AI services. Lastly, we should mention agentic AI or AI agent. And this is one of the biggest reasons why we have a radical increase in inference demand. Nowadays, not only humans, but also software components are calling model APIs, and we believe this agentic AI increases the amount of API calls by up to 10x. The problem right now is that despite this rapid AI adoption, developers in the company are wasting months setting up infrastructure and running the GPU infrastructure instead of building their products and focusing on their core value. First of all, of course, the most important part is GPU cost. How can we reduce them? Because of the rising GPU cost, they are cutting into your profits, and this is especially important when you want to scale your AI service. The next one is we need specialized optimization for different types of services. For example, let's say OpenAI's deep research. People can wait up to tens of minutes for getting response from deep research. But for other type of applications, let's say we have typical chatbot. In that case, people expect the service will give response in a few seconds. So depending on the AI service that you want to run, we have to apply the optimization differently. Lastly, we should mention the infra operation. How can we manage the infrastructure efficiently without the minimal human effort? Because of this, optimizing Gen AI inference is becoming more crucial for the success of your AI business. And we roughly have two types of goals. First, we want to keep our users happy with our application. And second, we want to manage our cost. To keep our users happy, we want to keep the generation quality as high as possible with low response time. And to manage the cost reasonable, we need high throughput from our model API, and so we can reduce the GPU cost. The challenge is these goals often have trade-off relationship between each other, and this is going to be the main topic of this session. FriendliAI is a GPU platform for accelerated AI, and our approach for handling the challenge is to consider trade-offs in the context of application scenarios. Based on this principle, we built our software and infrastructure from scratch, and now we are growing fast, and now we are serving hundreds of billions of tokens every day. We are trying to make our platform as simple as possible and easy to use, and now so you can run hundreds of thousands of Gen AI models in the Hugging Face Hub within just a few clicks. So as demand for fast and efficient AI increases, researchers have devised more advanced optimization technologies for accelerating this kind of very expensive workload. So we can't name all of them, but I have brought a few important technologies here. So starting from batching, we need to develop an efficient kernel to fully harness the full computational capacity of GPUs. We need to choose the right quantization method for our application. We need to employ caching, and so on. So these different optimization techniques have different implications on model quality and response time and throughput. So we have to carefully choose what to use. But with FriendliAI, you don't need to worry about these complex optimization spaces because we provide a good combination of these optimization spaces based on our long experience. This is possible because most of the optimization technology share the same underlying principle. That is, the optimizations are mainly built for mitigating the same problem, memory bandwidth bound. So this graph is showing the classic roofline model for analyzing hardware efficiency. So at the x-axis, we have arithmetic intensity, and y-axis, we have attainable flops. And the green dotted line shows a boundary between memory bandwidth bound and compute bound. So the situation when you run Gen AI models is it's naturally very bandwidth bound, and we need to apply optimizations to make it compute bound. So it means that we want to switch from this area to that area. This is because the nature of LLM inference. LLM uses autoregressive decoding, and it generates one token at a time. So this is very memory bandwidth bound, and we need to solve this problem by applying various optimizations. So the most important one is batching. Computations on GPUs incorporate two types of input data. The first one is model weight, which is shared across multiple requests, and the second one is activation. So if we can group multiple requests from different users together and run it at once, we can reduce the amount of data that we need to read, and therefore we can increase arithmetic intensity. So this enables transition from memory bound to compute bound reason. So let me introduce an important technique in this area. So it is named continuous batching, and it is invented by me at FriendliAI. And it's mainly devised for handling early finished and late arrived requests efficiently. But we cannot conclude the story for optimization because it often have trade-offs between with other optimizations. One prominent example is batching and caching. In the context of Gen AI inference, caching means reusing tensors stored in KB cache. And this is mainly used for skipping prefill computation for the overlapped part of input tokens. We often have overlap in the input tokens between requests because we may have a long system prompt, or we have shared context between multiple requests. For example, the shared documentation for different requests. We also need to handle multimodal data as well as text efficiently in the caching system, and we need off-GPU variant support, and of course, at large-scale deployment, we need cache-aware routing between replicas. The point is, caching has a trade-off relationship between batching. Just like ordinary caching, KB cache in recent AI systems have two roles. The first one is scratchpad memory for handling the current batch of requests, and the second one is storing KV tensors for future reuse. If the working set does not fit into the scratchpad space, the system will slow down significantly. So this is why we have a trade-off relationship between batching and caching. So when we need to increase the batch size, we need to carefully think about it because it may hinder cache hit rate of your application. We also have quantization also have a trade-off relationship between the goals. So quantization may degrade your generation quality. So when you want to use it, you have to be careful whether it's good enough for satisfying your end users. So I want to highlight at this point. So we have our own FP8 quantization method, and it preserves the model quality while speeding up the execution. So based on the techniques that we built and researched, we have a product named Friendly Suite. Friendly Suite is mainly composed of two components. So first, we have container microservice at the bottom level, and on top of that, we've built fully managed cloud service. Friendly container you can think it as a simple Docker image that you can pull from our image registry and deploy it on your Kubernetes cluster. We provide a good combination of optimization technologies, and so we can deliver GPU cost reduction and fast response. For the fully managed service part, I want to talk about Friendly Dedicated Endpoints. It's a fully managed service running on our cloud infrastructure, and you can easily pick up a model from Hugging Face Hub and deploy the model within a few clicks. Of course, we provide other functionalities like high availability, auto-scaling, depending on your incoming traffic, and intelligent routing between replicas. I will show you a demo video.
Now you can easily deploy models directly from Hugging Face Hub with friendly endpoints. Just go to Deploy Options on Hugging Face model page and select Friendly Endpoints. It's that simple. You can deploy a model with just one click. Once the deployment is complete, head over to the Friendly Suite to access even more powerful features. Now you can enjoy the fastest and cost-effective inference with FriendliAI's GPU-optimized inference engine.
Yeah. Before ending my session, I want to share a news. This week we launched a promotion program. So we give free $10K credits. So if you're interested, please check out the QR code here and apply in 2 minutes. And we are also running a booth over there, so please feel free to come to our booth and let's talk. Thank you.